Okay, we'll continue with part B. To the nearest whole number, how many gallons of water are in the tank at times t equal 18? Well, our function for the number of gallons of water, or the amount of water in the tank, both of those are synonymous, I've already given by a of t above. So that's all that I'm looking for here, is I'm looking for a of 18. Now the integral part of this, we already have a prime of t in the calculator, and that's w of t minus r of t. In our case, that's the y1 minus y2 in the calculator. So we want to integrate that from 0 to 18. In this case, t would be 18, and add 1200 to that. So I'm going to go outside to the main screen. I'm going to do 1200 plus math option 9, which is fn int vars yvars function y3 comma x, the variable of integration, from 0 comma to 18, and I end up with 1309.788, and again this should be rounded to the nearest whole number, so it's 1310. And since I defined the function above, a of t, as an integral defined function, I don't need to rewrite the whole thing. I can just write a of 18 equals 1310. I can refer to function a of t without having to rewrite it. The next question asks at what time t for 0 to 18 is the amount of water at an absolute minimum. So what we're looking for is where does a of t, since that is the number of gallons of water in the tank at any time t, where is that at its minimum, at an absolute minimum. Now since the amount of water in the tank is continuous and differentiable throughout those 18 hours, the extreme value theorem guarantees the existence of an absolute min. And furthermore, we know that it must occur at either a critical point or an end point. So because we're looking for an absolute min or max, I'm going to set up a table showing my endpoints. Now I also need to find any critical points that I have. Those will be zeros of a prime of t. And a prime of t is my w of t minus r of t in the calculator. So I'm going to go back to the calculator. I need to set up a window that will allow me to see the function carefully or accurately. And so it goes from 0 to 18 by ones, and then I just set up from negative 50 to positive 50 by fives for the y values. And if I go to graph, I'm going to get a graph that looks something like this, and I can see that there are two zeros on 0 to 18 somewhere. One is around 5 or 6 and the other 12 or so. So I need to find those values. Second calc 0. The first one is between, say, 3 and 8, somewhere in there. And I guess, so it's 6.495. And I'm going to save that value. Second quit. And I say x store alpha a, and I have 6.495. Go back to my graph. Now you should notice at 6.495 we definitely have a minimum there, because the function, the derivative, is changing from negative to positive. There is a second zero somewhere between 6 and 18, and guess around 12, but I'm not worried about that because I know that that is a relative maximum there. Now let me record some other values that I know. I am told at the beginning that I have 1200 gallons, and then at time t equals 18 we've already computed that there are 1310. So here I'm simply going to take the integral and add to 1200, and I used alpha a for the upper limit. Now add the result to 1200, and there's my min.